Hey guys, today we're going to take a look and see if we can troubleshoot this ultrasonic cleaner. It's American Time Products Watch Masters. It's type A-1T, and this belongs to a friend of mine that I work with. And here's the thing about it: it's got tubes inside. So let's take it apart and see if we can troubleshoot it. But this thing was made by the American Time Products out of New York, and it was made in 1960. And it's ran good for a while, and he had a problem with it, and he noticed one of the tubes were glowing real bright. So he ordered some tubes and put another tube in it, and just didn't work. From there, he couldn't feel no vibration in the wash cups. Now this thing is got several other attachments that goes to it. I'm not sure just how much attachment he's got. I know it's got a spin dryer and some other attachments that mount up here and plug in here, and there's a another, looks like a tube port on the inside. But I thought it was a test port at one time, but I actually found out it's where another accessory also plugs into it. So it's a very interesting piece. The wash cups actually lift out, and you see this coil on the bottom of them. And there's also lids that go on top that you can put on and close up. But it's a very, very interesting piece of equipment. It's got a switch here for regular and dry. So you got a spin dryer that goes in it. And over here you got off, wash, rinse. And there's one more spot. There's a dot beside it, but there's nothing written there. And that's probably for some other function that can be added to it. It's just not written on it. And he basically just wanted me to get it back working. And I'm going to go ahead and tear it down. We're going to troubleshoot, find out what's wrong with it, see what parts we got to have. And I'm going to go ahead and do a good cleaning on this thing, polish up the aluminum, and make it look nice, kind of give it a good cosmetic restoration. So to get into this thing, we'll turn it over. And right here on the bottom, you can see that there's 4 legs. Now I've done a lot of researching online. Not a lot of information out here about these pieces of equipment. There's just hardly anything out there. You see several people talking about different ones, different kinds, different models. Again, this is the type A-1T, which is written on the front of it, but here on the schematic it says A-IT. And it says ultrasonic cleaner, American Times product, and the date is June 7th, 1960. I think it's very interesting that they would build an ultrasonic cleaner that actually have tubes in it. So we'll get the bottom off, and this is made out of, like, I don't know, it's not Bakelite, it's not cardboard. It's kind of like that material you would find on the back of old TV sets. But here's the circuit in it, and you can see we have a pair of 25 CD6s in here, and I guess that's for the I'm gonna say it's for probably oscillation, creates the frequency for the ultrasonic cleaner. There's a timer in place, there's a transformer, and if you noticed through the schematic, let me Get you zoomed in a little closer. So as you look at this, there's your AC plug coming in, goes through a 5 amp fuse through the timer. There's a fan that just goes off to the dryer unit, and we got another transformer for the filament, and the filament comes up and it runs in series through both tubes and come back. So that's probably like a 50-volt transformer. Then we got two capacitors here on either side of the line cord, and these are 0.022 at 3 kilovolt. Then you have your transformer, and what you do not see is any rectification in this. We have a interlock switch, and that goes on up to one of the grids of the tubes. It splits off here. So very, very interesting piece of equipment. Okay, now with the legs and the bottom off, we should better turn this right back over. And I'm already seeing some issues that's probably contributed to this failure. Now this top should be able to work right off. There we go, we'll get this out of the way. You can see it's got a guard on the top that covers the tubes. There's a blower motor, it's your timer. If you notice here in the back, there's an RF cord just like in an RF amplifier. And there's also a plug here, and that's for one of the attachments that sits in and plugs into here. Here you can see the two 25 CD6s laying horizontal. Whenever I see tubes laying horizontal, I do have to question a few things, because it's never been a good idea to lay beam power tubes in a horizontal position, because if the filament gets hot, they sag. They can actually vibrate and touch the cathode, and if that's happened, you're going to get an internal short. It's going to damage some things. So when we turn it over, I'm already seeing two things right here that seems to be could have caused the failure. You see this big old green ohmite style wear round resistor is completely turned black right in the middle here. So that resistor has been pulling quite a bit of heat. And again, looking here at the schematic, we can see that this one side of the secondary to transformer, that resistor goes through that lead that comes on up to the plates of the tube. So that's a 5 ohm 10 watt resistor, and this basically been baked, which telling me that's probably an issue with the tube also. I'm going to go start by removing this plate. Now we can get to our tubes to get them out, and all I'm going to do is put this plate back on, but I'm going to keep that aluminum shield out. So you can see on the bottom of the tubes we got this locking base here. We'll pull the tube caps off. Press in both sides. Should be able to wiggle these tubes right out. That's one of them. I want to keep them separated so I'll know which side they were on. This way I know which position it was, because I want to test these tubes and see what they're like. And these are General Electric's 25 CD6 GB, made in the USA. It'll be interesting to look at where this resistor is and seeing which tube is the closest to this resistor, and see how these tubes check out. Okay, I got the old night tube tester set up for 25 CD6, and we'll go through and do a short test. And that short's on pin 7. And it should short on pin 7. And we'll do a test on it. And you see that well over at 100. Now this doesn't do a emissions test. But this tube here checks good. Now this is the tube that was on the outside that is closest to that resistor that's burned up. I'll let that settle off, then I'll adjust the AC line to the test line. Alright, I gave that a few minutes to warm up, and seven shorts. That's the only short that I see. So that looks good. And we'll test it. And that's checking 0. So that tube is basically no good. I'm going to crank the filament voltage up just a little bit, and nothing. Nothing at all. So that tube is dead. .25 CD6 GB, General Electric, just like the other tube. So I'm going to just take a Sharpie and I'm going to write this one as bad. Okay, we got this burnt resistor here. I want to give this a check out. See where it's at. I think I'm going to have to loosen it up and get the terminals turned around just a little bit so I can get it tested out better. Leads on it, that'll read. 5.4, well, about 5.4, 5.3 ohms. So it's checking good, but it's definitely going to have to be replaced. Okay guys, so I'm going to start troubleshooting under the chassis here. And we can look here and we can see any capacitors. There's a 0.022 on either side of the line cord. We've got a C4, which is a 0.0153 kilovolt over here. We got another, which is C3, 0.0153 kilovolt coming off the plates. And there's a 0.1 over here. So we have no electrolytics in this circuit at all. What it looks like, these are going to be ceramic style capacitors, this one and this one. And what I mean by ceramic style, the big round oil field. There's no diodes, no rectifier. It runs fully on AC. That is our 5 ohm 10 watt resistor, and you can see that's feeding off the transformer. Goes through this resistor and then goes up to the plates of the tubes for the high voltage. But it goes through one of those ceramic style capacitors. Now as you can look around inside, you can see all this black stuff down here on the chassis. I don't know if that's been stuff that's been spilt into it, or if it's old grease or what it is, but we'll have to get all that cleaned up. Now one of the interesting things I want to show you is just the way this interlock system works on this thing. You can see here it says interlock. So when you got the cups out, it actually shuts the high voltage off to the tubes. And the way this works is that when those cups come in, they contact a cylinder that pushes a micro switch in, and also makes contact to ground through these bars here, and I'll show you exactly how that works. And again, you can see just how dirty all this stuff is. But here is that interlock switch, and you see all it is a piece of aluminum tubing that lays in here. So when there's nothing in here, this tubing is just up against this stop just when the pressure of the switch. And when you insert the washing cups into the system, I'll put my finger here. You can see how it pushed this over, and then I'll insert the top one. So you got to have both of them in, and now it has that switch engaged. When this plate is over it that holds it all in place, and the bottom of these cups are grounded by these bars here that are also very dirty. If you notice, it's even got that green stuff on it. So all this I'll have to take out and put in my ultrasonic cleaner and clean them. I thought it'd be very interesting for you to see how this right here is designed. Very simple but yet effective. And when you take the cups out, you can hear the switch click. And that shuts it off. So a lot of cleaning to do to this thing. Alright, I went in and took the faceplate off so I can clean and polish that up, and took the knobs off and the terminal strip for the interlock, and got all that in the ultrasonic cleaner. What I'm going to do now is go through and try to get all this green looking corrosion off that's everywhere. You see it's all around the bolts in different places here, and just using a brass brush. And that stuff just comes right off real nicely. So I'm going to go ahead and get all this cleaned up. You see some around some of the rivets here on the bottom. It's still got that green corrosion, so if these are ground lugs, they're not going to make very good connections. So we'll have to look at that underneath and see if they're actually using for grounding, because I'm pretty sure that corrosion is seeped all the way around this rivet, and you know that's going to keep the rivet from grounding to the chassis. Or it's the outer part of it, it just scrubs right off, so no problem at all. So I'm going to go and get this thing cleaned up. I'm not going to bore you with showing the cleaning process, so I can get the chassis back looking halfway decent. Guys, I've been doing a lot of cleaning mostly, and cleaned the switch, replaced this 5-ohm 10-watt resistor with a Sprague 5-ohm 10-watt resistor. This capacitor, it appears to be okay. I'm going to see if I can order 2 new capacitors and go ahead and just replace them. I don't know what kind of luck I'll find out at finding 0.015s at 3 kilovolts. But I'll look around and see what I can come up with. I don't have the protective covering on this, but I've got it sitting in here, snapped in place, put back in the circuit just for testing purposes. I've cleaned the micro switch. The interlock tube has been cleaned. So I can get that back down in place. We'll have the bottom cover for that with the little spring-loaded levers that the cups set on. So we'll get those bolted back in place. We can get this thing powered up and test it, then we can see what all is working and not working. That will make it a whole lot easier to finish checking out. I almost feel like the main problems with this unit, with there's so many dirty connections that it probably couldn't make the correct connections that it needed, and that one tube was burnt out. But we'll see how it goes. I've got the control knobs cleaned, and you can see it took the white writing off of this knob, which we'll have to put that back. Also have a replacement 25 CD6 General Electric tube, and we'll check it for shorts. Shorts on pin 7. That looks good. Set the line voltage and we'll test the tube, and it's reading just about like the other good one did. So on the grid of these tubes on the back, we've got several 47 ohm resistors, and looks like a 1500 ohm down in there, and these 47 ohm resistors are in the grids. So if we look at our schematic, we can see there's a 47 ohm and a 1500 ohm, and we need to check these and just to make sure that they are okay, or if there's any problems with those resistors. Because if not, you know, a lot of people will, especially working on amplifiers, will overlook certain resistors. These on the bottom of the tubes are very important to make sure that these grid resistors are working fine. So we got two 47 ohms, and they look to be parallel across these grids, so we need to check those out and see what they are. So what I'm going to do is I'm going to have to unsolder one end of them. Aha! Looky what I found. Let me zoom you in on this. So this 47 ohm resistor, as you can see, is fried, and it's broke completely into. Yep, so I'm going to have to get these out of here and just go ahead and replace all of them. So the schematic shows one 47 ohm resistor in series with another 47 ohm resistor going to the other tube. But in reality, the resistors I poured out was two 47 ohms in parallel. And behind this coil, there's two 47 ohms that come over. So again, the schematic is a little different than what this circuit is designed. So it's probably some updates that's been done, and the schematic was never changed. There was also a 470 ohm resistor over here that was reading about 600 ohms. So I went ahead and replaced that. The two big 5 watt resistors underneath were good. The 1500 ohm resistors are checking good. And I checked this capacitor. It's a 0.1 under the bottom, and it checks okay also. So I'm going to leave that for the time being. I know I got some, so I want to just get it tested out and make sure it works the way it's supposed to before I go and replace that. But I'm going to replace it. This domino capacitor, I have to look it up, see what the value is, but Usually in this type of circuit, these don't fail. You can get silver migration in them, but in this type of circuit, the way it is, it's probably going to be okay. Okay guys, come to the conclusion. What had happened is when that tube flashed out, it actually took these 47 ohm resistors out. If you noticed, I told you they had two in parallel on each one. So it looks like somebody had replaced them before and said, okay, if I put two in there, it won't blow them. Well, what they done, you know, if you put two 47 ohms in parallel, you're going to have half of that one resistor. It'll double the wattage, but you know, it's going to half the resistance. So here's all the parts that I have removed. That's everything. There was also this little spring. I don't know where it came from. It's very corroded. It was also trapped underneath that interlock. It was just laying in there. So it looks like that was a something that had got dropped in there. I went ahead and replaced this 0.1 with a orange drop, and you can see it hiding in there. This 470 ohm been replaced. The two 1800 or 1.8Ks are fine. They check spot on. The 1500 ohm resistors check good. But after I ran this thing for a while, I noticed that you can see the filament glow in the tube, and down here at the base, the pipe around the filament was turning cherry red. And I cut it off. I moved this tube to the other side just to see if there was something in that circuit, you know, that was causing the problem here on the schematic. So I just moved this tube over here, replaced that one, and the problem followed the tube. But the whole end down here at the bottom of the filament tube just glows cherry red. And after running about 3 or 4 cycles, it blowed that 47 ohm resistor. So I replaced the resistor and I moved the tube back over here. And that was from the first one that blowed. That was on this side. And after running it about 3 or 4 more cycles, it blowed the resistor on the other side, following that tube. So that tells me that when that tube gets heated up, that filament is probably touching the cathode. And the harder it gets, the closer it gets to it, until it blows the red resistor out. Now I've took the old tube that was bad right here, that you know would not show anything on the old light tester. It shows a little bit on the Hitchcock tester. So the tube does work, and I've done verified it does work. It just doesn't, the output of it is so low that it, you know, it takes about 2 or 3 minutes for it to start oscillating the water. So what I'm going to go ahead and do is order 2 brand new replacement tubes. These tubes are under $6 a piece. Now I do have some 6 CD6s. You know, you could put in here and add another transformer, filament transformer, and run them, but I'd rather try to just keep it the same as it is. So I'm going to go ahead and order up 2 brand new, or new old stock 25 CD6s and put in here, and I think that'll solve all the problems with it. So anyway, I hope this was something you can learn from. I know I sure did. Very unique circuit, that's for sure. Never seen nothing quite like this. But I'll go ahead and get these tubes ordered up and we'll get them put. Alright guys, the new tubes have come in and I got it sitting here running, and I've been running several cycles through it and seems to be no problem. The other replacement tubes that he sent one with it when he brought it, and I had a problem with one of those tubes, so he sent me another one. Now these tubes are gassy and they're arcing. The new tubes are not the same brand. They are matched, where they have about the same emissions readings, but one's a Tonsol and one's an RCA, but they're pretty much matched. So it looks like that's taking care of the problem, and the filament tube is not glowing hot in these, so it looks like it's running okay now. Okay guys, just went online, Tube Depot. I decided to go ahead and order from them because I've ordered quite a bit of stuff from them, and they've always stood behind their products. Paid a little bit more for the tubes, like $8.95 a piece, so it's not bad. Whole total thing was $22 with shipping. Alright, thanks for watching. Hope you enjoyed it. Hope you learned something from this. I know this is the first time I've ever seen one of these, and it's a very interesting piece of equipment. So leave your comments down below, guys. I'd like to hear from you, and we'll see you in the next video. Bye now.